Hi there. We're going to look at some nuclear decay practice problems. Now, you probably already turned this in. However, it is worthwhile to think about how to do these. And then for your next worksheet, which is due Monday, you'll have this video and this answer key as a reference. So first of all, before I go through a couple problems, it is worthwhile to know all 5 types of nuclear decay kind of off the top of your head. So the first one is an alpha decay. So here's our 5 types. And with each decay type, you should know the type of particle. So the first one is alpha. Get that spelling right. And that is, as we said, an alpha particle or a helium nucleus, which has 2 protons and a mass of 4. The beta is just an electron. It's kind of good to know these, maybe to make 5 quick note cards. Positron which is a positive version of an electron. A gamma particle, a gamma ray, it's not a particle, and it has sometimes been written as 0, 0 because it has no mass and no charge. And then the last one is electron capture. And again, it's just the same. Clean that up a little bit. Just the same as a beta particle, but it just happens to be on the reactant side. Okay, so looking at these, I want to talk first, number 4, the second example under C is neon. And this one, because we're told it's a gamma emission, and if you see this little asterisk right here, just like in the above example, that just means this is an unstable nucleus, but no particle is going to be emitted. Therefore, your product is the exact same. So gamma is kind of a nice one because you'll just write neon again with the exact same numbers. No asterisk because it's more stable. And we're just going to say gamma or gamma 0, 0 as your answer. For all of these, it's very worthwhile to have a periodic table. And I'm going to erase the answer to this one and see how we got carbon 614. There we go. Okay, so if I look at a neutron being bombarded into nitrogen 14, it looks like a proton or a hydrogen nucleus is made, also the same, it's the same thing as a proton. So what that's left over with is something else. So the best thing to do is to look at the numbers and see that the bottom numbers here add up to 7. So that means on the right, they also have to add up to 7. Since hydrogen already has a 1, this particle has to have a 6 on the bottom. 6 plus 1 equals 7. And because the top numbers add up to 15, that means the numbers on top have to add up to 15 as well. So 14 plus 1 gives 15. If I look on my periodic table, the only element in the universe with 6 protons we call carbon. So that's where we get the carbon here, carbon 614. So just a brief review. Make sure you know your 5 different types of decay. And once you know that type of decay, you can put that into a nuclear equation, either having it as a product or in the case of electron capture as a reactant. If you don't know what type it is and you're given this other information, like in these examples, you're just going to make sure your numbers add up for that last particle that is made.